Now I want to finish the if theorem and prove the third part of the if statement. So I would need to show that the invariant in the guard of the loop and the second guard for the if imply the weakest precondition of the command corresponding to the second guard, the invariant again. I'll do it very similarly to the last video when I was dealing with the first guard. I have the weakest precondition of an assignment, so I know it's textual substitution. Everywhere in the invariant I see an x, I'll replace it with x minus y. Then I'll use the greatest common divisor fact that the GCD of x minus y, y is equal to the GCD of x, y. And I'll do the same trick as before and notice that the interval 0 less than x minus y less than or equal to x hat is equivalent to the interval where y is less than x is less than or equal to x hat plus y. Then I instantiate and notice that the two guards in this case simplify to x is greater than y or y is less than x. And so using the same kind of strategy as to decompose the interval here into the part where 0 is less than y is less than x, which is less than or equal to x hat, or x is between x hat and x hat plus y, I notice that I can again use weakening and strengthening, and this expression simplifies to true because there's the same types of commonality in the two sub-predicates of the implication as we saw in the last example. And so this shows that the third part of the if statement holds, and so in fact it is going to be the case that if the invariant holds before we do an iteration, once we do the iteration the invariant is going to hold again. So we're on our way.